Welcome back for part 2 of the video, Life Cycle of Stars. Today we're going to talk about the final stages for red supergiants. Supergiants are so massive that they use fuel much faster and produce a lot more energy. You would think that because they have so much more hydrogen and helium that they would live a lot longer, but because of their size they actually run through fuel much faster. So they have very short lives, and at the end of their lives they typically explode in a supernova. After the supernova, the material at the center can form a new star called a neutron star. If the neutron star starts spinning, it's called a pulsar. If there are massive leftovers, the star might form a black hole. Here is a short video on black holes.
The bad boys of astronomy. Black holes inspire well-deserved wariness and strange fascination. But what exactly are they? Scientists, harnessing the incredible power of Chandra, have discovered that black holes play a critical role in both the development and demise of stars and galaxies. While astronomers have long known that black holes existed, it wasn't until Chandra was launched in 1999 that some of their elusive secrets were revealed. With its insightful perspective, Chandra has shed a revealing light on the dark mysteries of black holes. Focusing on the deepest depths of space, Chandra has witnessed the gluttonous eating habits of some black holes.
And in those regions where the X-rays are deficient, where the gas voids exist, is the same regions where you see the radio lobes, these jets and lobes that are formed from the radio. So you know that energetic particles are being shot away from the black hole by some kind of mysterious process, and they're clearing the gas away, they're pushing the gas aside. Because the gas has a density and a temperature properties that we measure in the X-rays, it's very easy to calculate the amount of work that's needed to clear these voids. So you can actually measure the energy that's carried out by these jets and particles.
However, not all black holes mean certain doom for their neighbors. Consider, for example, one known as Sagittarius A star, a black hole churning at the center of our own Milky Way galaxy. Unlike its more malicious siblings, this black hole appears to be protecting a flock of young stars instead of eating them.
With Chandra, we're able to measure the density and temperature of the gas just outside the black hole at the center of the Milky Way galaxy. And there's plenty of gas there, and it's hot. And we should see, even with conservative theories, instead of 100 billion times the amount of radiation that we see, we should see 1 billion times or some 100 million times. It doesn't matter. It's a large factor greater than what we see.
Equal parts stellar destroyers and cosmic creators, Chandra's black holes exhibit dual nature. While some black holes voraciously devour gases and galaxies, others coddle them, proving yet again that bad boys usually have a good side.
You might still have some more questions about black holes. It's kind of a pretty complicated topic, and we are going to be talking about it a lot more in class and exploring it a lot more. But now we're going to watch a brain pop on black holes that simplifies it a little bit, and we'll explain a little bit more about them.
You know, you could help out. I mean, you want to play with my Stunner 4000 Galactic Starship set as much as I do, right? Right? Huh. Dear Tim and Moby, what exactly is a black hole? From Beatrice. This closet, that's what a black hole is. But to answer your question, a black hole is a region of the universe so dense it traps stuff in it forever. Right, well, scientists think there are at least 2 ways a black hole can form. One is through the death of a large star. Stars are kind of like big fireballs, and just like fire needs fuel to burn, so do stars. Normally, as a star burns its fuel, it creates a sort of push that counters the force of gravity pushing in towards the star's center. But eventually the fuel runs out. When this happens in a large enough star, the force of gravity makes the entire star implode. It collapses in on itself and creates an incredibly dense region known as a black hole. Most astronomers think that our galaxy, the Milky Way, contains millions of black holes that form this way. Oh, now you've got enough energy to get up. The other way scientists think a black hole can form is through the collection of matter at the center of a galaxy. When billions of tons of dust and other matter get together in the middle of a galaxy, it can collapse in on itself to make a ginormous black hole. There's probably even one at the center of our galaxy, and that thing you don't want to mess with. Well, you can't really see a black hole. One of the crazy things about them is that nothing can escape their enormous gravitational pull, not even light, so they're completely invisible. Black holes do have a sort of edge, though, called an event horizon. An event horizon is kind of like the point of no return. It's the boundary for a black hole beyond which nothing can ever escape once it's sucked in. No one has ever seen an actual event horizon. But astronomers say we may soon be able to see one with the help of some cool new technology. You know, nobody really knows what happens deep inside a black hole. Physicists think it's pretty likely that some weird things go on in there. Like, we do know that no person or earthly object would ever survive a trip into one. They would get ripped into individual atoms in no time. Okay. The universe is measured in something called space-time. In the everyday world, matter takes up space in 3 dimensions: length, height, and width. But time is another dimension that works very closely with the other 3. It's how we can see and measure events happening. So if you take time and add it together with the other 3 dimensions, you get space-time. Relax, I'm getting there. Scientists often say that space-time is like the never-ending fabric of our universe. According to Albert Einstein's theory of relativity, the fabric isn't just flat, it bends around objects. This bending represents the force of gravity. The more massive the object, the stronger the force of gravity is, and the more space-time is bent. Imagine you have a small ball representing the sun. Take this tennis ball. If you place it on a piece of fabric representing space-time... Hey, Moby, can you help me with this blanket? See? The fabric bends a little because the sun has mass and a gravitational pull. A black hole, though, is much, much more massive, so its gravity is way, way stronger. It'd be like putting a bowling ball in the fabric. The deep well it creates means the force of gravity is very, very powerful. And, as you can see, the distortion in space-time is extreme. Yeah, and what's really weird is that in reality, the well for a black hole is so deep, it actually creates a hole in space-time. So if anything ever fell into the hole... Hey, wait a minute. What the... That is so weird.
So let's take just a second to review the life cycle of stars that we talked about. All stars start out forming from a nebula of gas and dust, and then most stars end up in what's called the main sequence, and this is where they're burning hydrogen and helium through fusion to produce energy. Eventually that fuel runs out, and they stop going through fusion. And then what will happen is they will start to cool and expand outward. And this is when they become a red giant or a red supergiant. If a star is the size of our sun, it becomes what's called a red giant. If it's 100 times or larger than our sun, much, much larger, then we call it a red supergiant. Now the red giants, like what our sun will become, don't end in really anything spectacular. They just end up, the outer atmosphere just slowly leaves them, and you're left with the leftover center, very, very hot, dense center of that old star. And that's called a white dwarf. And white dwarfs can still shine for billions of years, even though they're not going through fusion anymore, because they're still very, very hot. Once they stop shining, then they're called black dwarfs. Now, the red supergiants typically end in a much more spectacular way in a supernova or a stellar explosion. And after that explosion, how much mass is left over decides its course. If there's a lot of mass left over, then it could become a black hole. If there's not as much mass, then it can form a neutron star, And then if that neutron star starts spinning, then it's called a pulsar. So there's a lot of different possible directions for the life cycle of a star to go, and most of it depends on how much mass there is, how much matter. We'll still continue to talk about this in class, but I hope that part 1 and part 2 of this video helped you to understand a little bit more about the life cycle of stars.